My name is Alex Krejci. I'm a systems engineer at DMC. I'm involved in a lot of different projects across a couple of different technologies, but I've done a lot of work in embedded here in product development and testing and experimentation.
Cool. What platforms have you worked in?
I've mainly worked on the MSP 430 here, which is a Texas Instruments low-power microcontroller. I've dabbled in a couple other different technologies, but that's been the core of my work.
What what's some project examples?
Of different things I've worked on, or
Things, yeah. If you want to pull these anything.
yeah. It's been, well, so primarily with the MSP 430, I've worked on a couple of different sort of interfaces and stuff with it. The device is a C language, so not object-oriented, but has some libraries and stuff you can use. And the MSP 430 specifically has UARTs on it, I2C and SPI communications, as well as ADCs and some other functional modules. So we've done work interfacing with all of those. The ADC in particular, we've done voltage measurements and power monitoring, so switching between battery and wall-powered devices. I2C and SPI we've used to interface to other chips on a board, allowing us to utilize chips that are stronger in functionality for certain things, or talk to an LCD chip to display stuff on a handheld device. On top of that, the MSP is an interrupt-driven device, so we've done, with those included modules and the functionality of it, we've programmed through an interrupt architecture, which allows us to interleave different functionalities and capture some high-speed data and develop for a battery-driven application.
What industries have you worked in?
Industries, I've worked in sort of an industrial manufacturing industries, as well as sort of commercial products inside those industries, so developing the product for that industry.
Why would somebody choose DMC for embedded programming?
So I think there's a couple of reasons somebody could choose DMC for embedded programming. First of all is we can sort of do the whole line of embed development. So in particular, on our last big project, we did everything from development to commercialization. So typically you'd start with like a development board for the typical platform you're using. So this is a MSP 430 development board. So this you get from Texas Instruments. It just provides access to everything that the device does, and you can build up a potential device and test it. So we start with this and confirm that it can do what we want it to do. From there, we moved on to a prototyping board, which allows us to put everything else that we're expecting and put it on an actual board and test its functionality, but not in a final package. So this provides us with a lot more testing capabilities, and it's easier to modify things if something's not right on there. And then once we've confirmed that it works on here, we'll move to a commercial application, which would be the final board design. And then this is what would be placed in a final product. So we're doing more than just the programming. We're doing sort of the full development and testing of the product, which is very valuable to a customer. On top of that, DMC is also very strong at programming and developing unique architectures. So in terms of battery life and battery management on embedded applications, which can be very important, we can develop the specific architecture that we need to get the most out of that device, whether we're shutting things down or writing the best or fastest code that we can to save the most battery, doing things as efficiently as possible.
Are there any other specific projects which you can say? Probably
Not a whole lot other, yeah, I kind of have to talk in generics,
Yeah, that's okay.
I think. I don't know.
Um,
Talk about architecture.
You kind of covered this, but can you do like an overview of like what is embedded programming in 2 sentences? Is that something like, because I
Yeah.
don't know anything about it, so it's just like something to kind of give an introduction overview of what it is.
I'm not.
Or is it more complicated?
It's like a very broad term.
Okay.
I mean, it refers to anything that it really, I guess, it depends on who you're talking to too, but I consider it referring to any sort of device that is either compact, low-powered, or sort of simple, and also any device that directly interfaces with I/O and communications. So it differs from something like a CPU on a computer in that the CPU generally needs a lot of other support hardware with it. A microcontroller is usually all in one package, so you can get more basic functionalities in a really small, simple design that requires very little power, versus something like your cell phone or a full laptop that can do a whole lot, but also has really high requirements for power and usability.
Okay. Do you think you could say that just a little bit shorter? And
Yeah.
say, is it embedded programming, is that the right term?
Embedded development, embedded programming.
So just say embedded development is, or do you
Yeah.
like to say that phrase?
Okay.
Like you listed devices, maybe that's all.
Yeah. Yeah, I can. So, embedded development is the development of microcontrollers and other small, low-powered chips to be used in compact and portable devices.
Yeah, that's
Okay.
Perfect. Is there anything else on your list that we didn't?
The only other big thing that I've worked on is sort of more in terms of battery life and management and low-powered applications, I guess. So,
Okay, I'll talk about that.
yeah,
What project was that? Or?
this is all CDI, but
Oh, yeah.
I like hiding that fact. So DMC development on a device that had very strict power requirements and that the customer wanted to get as long a battery life out of it as possible. There are certain things on the device that had high current draws and required our code in the specific microcontroller to draw as low of current as possible to offset the other high current draws on the device. So DMC went through a couple of different strategies to help this customer out. Particularly, we had a lot of experience in analyzing the current flow of the devices and predicting the battery life we're getting out of that, and then applying software tricks and hardware tricks to reduce the current and even it out across the activity of the device to better improve battery life.
Awesome. Yeah, everything that I said we were discussing yesterday.
Okay. You're like, remember what we talked about yesterday? Talk about that.
Was less than 24 hours ago. Hi, Matt. Do you want to introduce yourself?
I'm Matt Puskala. I'm an engineer and project manager here at DMC.
Can you give me a 1 to 2 sentence summary of what embedded development is?
Can I start by talking about what embedded systems are in general?
Yes, that'd be wonderful.
All right. Embedded systems basically means you're taking a small computer or microchip and putting it into some product and making it control it. And basically, embedded systems are all around us in everything that we touch today: microwaves, vacuum cleaners, cell phones, TVs, anything you can imagine. So there's a lot of product development involved in embedded development in general. Or I should say there's a lot of product development that involves embedded development.
So why would somebody choose DMC for embedded development?
I don't know if I want to answer that question directly. It's a difficult open-ended question to
Shall I rephrase?
answer. Yeah, sure. I guess.
What are some of the advantages of working with DMC on an embedded development project?
Well, at DMC, we've got a lot of expertise in a lot of different areas outside just simply embedded development. I mean, we've got a lot of great electrical engineers here that are good at circuit design. We've been through this process many times before. We know how to lay out a board. Software is what we do day in and day out, so we can do a great job of programming your system. At the same time, embedded systems are not in a vacuum. You know, they interact with the rest of the world in many ways. So we work with a lot of industrial systems. If there's an embedded application that involves industrial systems, we'd be a good fit for that. We are certified Microsoft Gold partners, so we do a lot of web development and application development that can interface quite nicely with embedded systems. Good example is we've developed a lot of embedded systems and also developed a website that goes along with them that the embedded system can communicate with. That can be useful for all sorts of applications. A good example would be if you want to push future firmware updates onto that system, you can do that. If you want these systems to collect data, log data, and send it back to a central location, it's good for that as well.
What platforms have you worked, embedded platforms have you worked on?
We've worked on just about any platform you could imagine. There's a ton of them out there, though. We've worked on ARM systems. We've worked on the .NET Micro Framework. We've worked on a lot of microchip projects. We've done some Arduino work, and we've done quite a bit of work with the Texas Instruments MSP430 platform. The Texas Instruments platform is pretty cool. They've got a wide variety of chips at different price points, but they're relatively cheap. They're low powered. They're full featured. They've got just about all the features you could imagine you would want. You know, SPI. They've got SPI, I2C. They've got a lot of I/O on them. They've got some flash memory on board. They've got a lot of low-powered options. They've got a lot of clocking options, so they're good platforms in general. The Launchpad, Texas Instruments Launchpad, is a fun, nice, cheap little hobbyist device that we sometimes use on our prototypes, and a lot of us here have used them on fun little projects at home as well. They're cool because they're only $4.30, and they're pretty easy to get up and running, and like I said before, it's pretty full-featured, so they've got just about anything you could imagine on them. And if you check out our blogs and videos, we've got some examples of some of the fun hobbyist things that we've done along with some of our projects for customers.
Can you tell us about any embedded projects that stand out?
Yeah, we did a project several years ago that was for, gosh, I'm nervous about talking about this stuff because there could be issues. Well, whatever. Yeah, let me choose. Let me choose something else. Let's see. Oh, yeah, I guess I can talk a little bit more generically about it. We did an embedded project a few years ago that was for a vending system, and the business model was that our client would own these vending systems and then put them in their customer locations, and then the customer would basically pay per the amount that gets vended out of them. So this was a situation where the system needed to dial home to a central office, a central location, and we also set up a website that would keep track and log all this data that these were sending out. And basically, the customer needed to use that information in order to build their end clients. And another cool feature is that we set it up so that it could push new firmware updates onto these remote systems. Every day they would dial home and see if there was a new update available and push all their latest data.
Are there any product development examples?
Yeah, let's see. Well, let me go this direction. Oftentimes, people will come to us with a concept, have a good idea of what they want, and then we can take them through the entire process of developing that product, from selecting a platform, figuring out what specifications they need, what features they need, from programming it, designing the circuit, putting together the circuit board, doing an initial prototype run and testing and debugging, all the way through helping set them up with vendors that can take over the full production process once they get everything up and running and ready to go. Sometimes customers come to us where they've already got an embedded system, but it's got some issues and they need some help debugging them. So we're not always taking them through the entire process. We work with customers in that setting as well. We can help them fix software issues, debug circuit problems. Sometimes they even need some help reverse engineering part of their system, part of their circuit when for some reason or another, some of that information and initial data is lost. What else? We can talk a little bit about Altium, maybe?
Yeah, I was gonna ask if there's any Ryan related, since he's not here, or is like asynchronous stuff.
Oh, yeah. Did Ryan talk about, or excuse me, did Alex talk about the asynchronous stuff a little bit, or
Yeah, a little bit.
did he talk about the asynchronous stuff at all, or? Okay, so yeah, I can talk about that a little bit. Tim maybe can as well. Let's see. So for circuit design and board layout, we use Altium, which is a pretty fancy, expensive, full-featured software. It's pretty powerful. There's a lot of things you can do there. Basically, you design your circuit, you input the footprints for all your parts, all your components, and then if you need to move things around, if you need to swap around pins, optimize, it works pretty well for that. It's a pretty cool piece of software, pretty powerful. On one of the projects that we were working on, it was a battery-powered product, so low power consumption was very important, and we actually needed to use an FPGA for it because the data that was coming in was very, very fast. So we needed a fast system, a fast processor, and we needed low power consumption. So we ended up going the route of throwing an FPGA in there that would communicate with the microcontroller, and at the same time we used a non-standard architecture of basically using the incoming data to actually clock the FPGA. That way it's not clocking regularly, and when there's no data coming in, it's not clocking, it's not expending energy. But when the data is coming in very quickly, it clocks very fast and is able to handle all that. It was a pretty ingenious, cool setup that Boris came up with. He's pretty good at coming up with some of those crazy ideas and implementing them sometimes.
Talk about industry marketing.
Yeah, I think we can talk about that a little bit. Well, I don't know, maybe let's stay away from that a little bit. Well, I don't know if there's a lot I can say about it. Just trying to think if there's anything else. Oh, yeah, okay. One of the real advantages DMC has in the embedded world is connectivity and connectivity to remote systems. We've devised systems that communicate on really old school technologies, for example, using an old analog modem to dial up, if you remember the old dial modem days from a decade ago or so. We do a lot of Ethernet stuff. We've done some Wi-Fi stuff. We've done some Bluetooth stuff. And we've also done some cellular stuff, basically embedded systems that use a cellular modem to communicate home, which is nice because then it's something that can be remote, out in the field, something that can be mobile and move around, but still communicate and connect home. Let's see. When it comes to programming languages, usually if you're in the embedded world, usually you're programming in C. C's a pretty cool, old school, classic language, pretty powerful. We've also done some work using .NET and C Sharp, using the .NET Micro Framework. I don't know. I guess that's kind of all I got. Can you think of anything else?
Covered all the major advantages we were talking about yesterday.
Yeah.
You did well.
I wanted to talk a little bit about the hobbyist stuff. I guess I kind of touched on that a little bit, so that's cool. I guess maybe I can talk about that a little bit.
What's in the box
Well, this is,
for those things?
yeah, just for these. Oh, I know what I was going to talk about. Yeah, okay. All right. So the embedded projects are fun for us because, here, let me start over again on that. The embedded projects are fun for us because it's actually something that a lot of us enjoy doing in our free time as hobbyists as well. So it's kind of cool to get to do something at work that you enjoy doing at home. We've hired quite a few grads from Northwestern that have actually won the robot competition there, which is pretty cool and something that we're proud of. Basically, every year at Northwestern, the engineers, generally the electrical engineers and the computer engineers, have an opportunity to build a robot, and each year the challenge is a little bit different. And we've had a lot of employees here that won first place over the years. Okay, I guess that's it.
We should have like an industry section for farming.
For farming.
All right. What's your name? What do you do?
I'm Johnny Sun. I'm a systems engineer at DMC, and most recently I've been working on a lot of embedded projects and programming lots of different microcontrollers for various product design and mostly product design projects we have around here.
Were you on the robot team or just the solar car team?
I was in both the robot team and the solar car team.
Can you talk about, Matt was talking about the robot team embedded stuff a little bit. Do you want to? These guys?
Causing trouble.
Stephanie, no walking, we're recording.
Stand right there for the next half an hour. Should I start over?
Yeah, if you want to talk about, because Matt had mentioned the robot team at Northwestern, how some people have been involved in that. If you want to talk about that with relation to embedded stuff.
Okay, so the robot competition at Northwestern was called Design Competition, and it involved programming a high-end PIC32 microcontroller to control a robot to perform certain tasks. And for the year of our competition, the goal of the robot was to basically hoard some tokens that were on a board and bring them to your goal or special scoring area, and while keeping them from your opponent's robot. And so our robot was really good at doing this because it had this gun that shot the tokens around much faster than robots could move because they're limited by what motors you can use. So it wasn't too complicated of a project, but programming the PIC microcontroller, it had like every capability. It had the most capability out of any microcontroller that Microchip offers. So we got to use the analog to digital functions. We used serial peripheral interface and I2C to communicate with various peripheral chips in our circuit, and we use a lot of the built-in functions of the microcontroller, like built-in timers and interrupts to make make our robot do what we wanted. So that was really cool, and that was my first experience with programming microcontrollers, and that got me started on all of the microcontroller work that I do here.
Did you win?
Yes, I won. We won.
What embedded platforms have you worked on?
I'm most experienced with the microchip PIC platform, PIC32, PIC18, PIC16. I've done a little bit of Atmel AVR programming, but I haven't really done any TI MSP 430 programming at all. But I'm excited to learn about other microcontrollers and embedded platforms as I work more.
What industries and projects you've worked on been in?
The industries of the projects that I've been working on have been mostly product design or on small or large scales. So on a large scale product design is this ice bagging machine, and that has a really complicated graphical UI. We programmed a touchscreen interface using using a PIC32 microcontroller, and that was really involved because we got a lot of experience with the microchip graphics library, and it just really leveraged a lot of the capabilities that the PIC32 microcontroller had to offer. And on the smaller end of things, scale of things, design products that control PID heating loops, and that would just be a much simpler microcontroller, much simpler, lower power microcontroller, but it would do a much more limited, have a more limited set of features to do what we want without having an overkill microcontroller.
What about marijuana?
What about marijuana?
Talk about it. Do you want to go maybe like the ice bagging machine? I don't know how much you can say about it, but kind of like give a project example. What exactly
Okay.
you're working on?
So for the ice bagging machine, it has to control these ice cuber machines that basically make lots and lots of ice cubes per hour, and then the ice bagger machine would take the ice cubes, drop them into this bag that it has opened until it fills it with a set amount of ice. We have the microcontroller reading ice weight from a load cell, and so it knows how much ice has fallen into the bag, and once it has filled the bag, it'll close and seal the bag, and then rip it from the spool that it's on and drop it into the merchandiser, so someone in the grocery store can come in and buy it just like you'd see at a normal like ice freezer in the grocery store. And the whole machine is connected to the internet, so we have either wired Ethernet capability or cellular modem Ethernet capability for it to communicate how many bags it's made, if there's any errors, or if it's low on bags, or any other messages it wants to send. And throughout the whole machine, there's lots of position sensors and temperature sensors and what have you for controlling what it needs to make in bag ice.
Do you have any other projects you want to talk about? That'd be good examples.
Right now I'm working on a project that involves integrating a wireless or a hold on. Right now, I'm working on a project that involves integrating a Wi-Fi module into an existing product. So it would be a drop-in replacement for an older, less capable Wi-Fi module. And so I'm just learning how to interface an existing product with the new Wi-Fi module and building a communications wrapper that will make it easy for the existing code to communicate with the new hardware with minimal modifications. So I don't know how much more there is about that one.
Maybe you mention why working with DMC is an advantage, maybe using connectivity as an example.
Okay. Choosing DMC for embedded programming is would be an advantage because not only do we have lots of engineers experience with microcontroller programming, but we have engineers with broad experience over lots of other platforms. So it would be really seamless for us to integrate microcontroller projects with on a larger scale with programs on, say, like Android tablets or with applications running on servers or PCs. We have lots of experience interfacing microcontrollers with databases on servers, and so where a pure microcontroller programming company might not be able to have as many resources outside of microcontrollers, DMC has a very broad experience base to leverage for any sort of project with any microcontroller applications.
What are some other reasons why someone would choose DMC for embedded programming? Product development or working on existing systems?
Yeah, we have a lot of experience debugging microcontroller projects, existing microcontroller projects, and we have a wide range of experience with lots of microcontroller technologies, and we're not limited to a certain company or programming environment. We're very hardware agnostic, but very skilled at working with any sort of embedded environment.
Are microcontrollers super fun?
Yes, microcontrollers are super fun. They do lots of fun things.
Like what?
Even making them blink lights. I had a very small 6-pin microcontroller, and you see this super simple tiny chip, but it's still able to do pretty complex tasks with it. So it's.
Should we talk about that project with just pressing the button? Can we feature that in the video?
We have buttons. See, look, it lights a light.
I think that's it.
That's it?
Yeah, I think that covers it.
Okay.